Hi everyone, thank you for coming to my session. Speed up your slow horizon logons. Who here has slow logons in their environment? Or who here wishes their logons would be better? All right, perfect. So I'm going to tell you a little bit about myself. So my name is Trentent. I used to work in healthcare, so these were my people. These are doctors, right? And their time is really valuable. It's really valuable in two ways. One way is money, financial, of course. The other way is patient care. When you can have more time for the doctors to look at patients, then they can actually be more effective in patient care. So that's something that slow logons takes away from them when they need to launch their desktops or applications and wait and wait and wait. So when I was working in this, what I found was slow logons cost a lot of money. In the environment that I was in, when we had 30-second logons, 1-minute logons, we would have the doctors log on maybe 4 or 5 times a day to their published applications, and that would be 5 minutes a day times 1,000 doctors times 365 days a year. And when they're getting paid $400,000 or something like that, it's really expensive. And then you take away the patient care aspect of it, not something that's conducive to a good environment. So that's the time that they lost when they were waiting. That's what it looked like. So when we got the logons down to 30 seconds, they got really excited. You used to have to sit beside them. They would sit there and be like, all right, I want you to actually witness what I have to go through. They'd click on the icon, they'd start their stopwatch. They'd be like, 30 seconds, this was the best logon I had today. And you'd be sitting there like stressed out as you're waiting for that Windows screen to eventually get to the desktop. So I made it my mission to make logons as low as possible in my environment, and we accomplished that. Back in those days, I think we got down to about 6 or 7 seconds for logon time. So we did a really great job at the time. So that's where my journey began. This is going to be a really information-dense session, so I hope you have your pens and papers ready, because here we go. So first thing you want to do when you want to talk about your logons is you want to essentially establish a baseline. But what you need to do is you need to understand the capabilities of your environment. So the first thing I experienced was that megahertz matters. It matters more than core counts. At least this has been my experience. Logon duration is a single-threaded process. Multiple cores doesn't help it as much as faster processors does. And this was borne out in Meltdown Inspector. When Meltdown Inspector came out, I did some testing. We had 2 different hosts in our environment, 2 different ESXi hosts, one running an E5 2680 2.7 gigahertz, and a brand new one running a 2660 V4 at 2 gigahertz. And what we found was the performance degradation of the 2660 was way more significant than the 2680 that was 4 generations older. So what we needed to do is we needed to change how we were architecting our future platforms to make sure that we were megahertz first over top of core counts. That meant more money had to be spent on hosts, unfortunately, but when it came down to patient care, it was important that the doctors got to their applications as fast as possible. Next, I found that CPU host utilization. Once you started exceeding about 30 to 40%, we would actually see logon performance degrade, and this is what it looked like. So after 30 to 40%, logon times are pretty consistent at any CPU utilization for the host level before that, but once we started to exceed that, we started to see that number ramp up. So I actually work for ControlUp. We've got tools here that can help you monitor and show this kind of information, but this was really valuable. So we set a threshold on our hosts. We did not want them to exceed 30 to 40% utilization. So we set that as our standard, and that's what we did going forward to make sure we had optimal performance. Next, keep NUMA vertical alignment. So if you don't know what NUMA is, it's non-uniform memory access. And so here's actually what it looks like. And Antec put this picture out, and it's a great picture. And it shows you how the memory is accessed across NUMA. So what you want to do is you want to keep in that green space. If you have to go out from one socket to another to access main memory on a different processor, you're going to hit an order of magnitude slower memory process. So that is going to slow down your logons. That's going to slow down the performance of your systems. ESXi, at least the guidance from what I recall last, was that you should not go over an 8V CPU core machine. Otherwise, you lose that NUMA capability. So you want to keep under 8 cores if possible in order to make sure that you're NUMA aligned. Next is to maximize performance, you want to make sure that your power management is set to maximum performance, whether that's in the BIOS at the ESXi level and on the virtual machine level. If you can set all those, you're going to stop the processor from turboing up and ideally sitting at its fastest possible speed. That essentially is what you purchased when you bought it out of the box. And the reason for this is because the changing of the frequency actually pauses execution until the frequency is switched to its new speed. And so when you have turbo boosting, when you have speed shift, when you have all these C states and stuff like that, execution of the CPU will actually pause until that frequency gets shifted. Intel has done a much better job on recent CPUs on actually how quickly they can change the processor frequency. But you can see that in the old days, it used to be around 120 milliseconds. They've got it down to about 60 milliseconds, but these are still milliseconds, not nanoseconds. This still takes time. So ideally, if you can, try to reduce your power management by keeping it at max performance if possible. Last is using vSAN or similar technologies. Obviously, having local storage, this has been my experience, has been much better than shared storage. When you have local storage, the traces in the wires are faster to your storage, so they actually operate a lot better. vSAN is a great technology, especially with the new ESA architecture and flash storage and NVMe for making sure at optimum performance. All right, so to understand your logons, where to begin? So the most important part is to enable proper data collection. Enabling proper data collection gives you the information you need in order to accurately assess your environment. If you don't have proper data collection, if you don't have the proper data, then you're not going to be knowing what you don't know. You're going to be flying blind. So the first thing I recommend doing is enable command line auditing. This is a group policy setting that you set within your group policy, apply to all your VDAs, all your VDI machines, and make sure it's there. This will actually enable some additional settings in the Windows security dialog, and this is what that looks like. So it enables this particular feature here, process command line. And we use that particular marker in various scripts that we have in order to understand when a process starts and ends. Because if you have 5 cmd.exe processes, without that command line string, you don't know which process is related to what. Next, enable print service logging. So by default, for whatever reason, Windows decided that this feature is disabled in logging. Make sure you just check that little box that says enable logging. There's various features in various applications and technologies that impact the logon duration, so they can make your logon wait until the printers are mapped before it actually proceeds to allow you to log on to a machine. When we enable this, we can actually track this within some of the scripts that we have that can help you identify that printers are what's causing you to have slow logons. Next, increase your event log sizes. This is insane. Windows 2000 came out in 2000 or 1999. The event log sizes back then were 20 megabytes. Does anyone know what they are today? 20 megabytes. It's 23 years later. Increase your Windows event log sizes. The sizes that I set is about 500 megabytes today, but really it's going to be based on your storage. Windows has exploded the number of event logs that you have. You don't need to increase necessarily all of them, but definitely the major primary ones, security log, application log, system log, and then some of these tertiary ones like WinLogon and stuff like that. Next, enable process creation and termination logging. So this is really important because this allows us to track when that CMD process has started and when it executed. There's different processes during the logon phase that directly correlate to certain technologies or certain phases. If we can track when that process started and when it stopped, we can tell you how long that phase was. So this is what enables tracking things like logon scripts, print driver installations, third-party CSEs, more, determining the duration of these by the start and stop events of those processes. So there's 2 methods to enable it. There's a legacy method and the advanced audit policies. This is what they look like. This is what the legacy method looks like. Microsoft strongly recommends you enable it on just one and make sure you stick to just one. Ideally, you'll be using the advanced audit policy, but if you're an old organization that has grandfathered in and you're using the legacy policy, that's fine. But just make sure you stick to one and don't have both enabled. Otherwise, you might get inconsistency in your environment. This is what the advanced audit policy looks like. So you can see it's under detailed tracking. Audit process and creation are now broken out into separate policies. Just enable success for both of them. This is what the event looks like. So you kind of had a screenshot of that earlier, but now with this event created, you can see at the top there's 4689, that's process termination. 4688 is process creation. Once we have that, we now have the ability to track how long a process took. Group policy preferences logging. So this is the client-side extensions that actually run when you're logging into Windows. So group policy preferences, how they operate, at least for the native Windows ones out of the box, is they're all set through group policy. And the real unfortunate thing here is that they were designed back in like Windows 2000. So you need to go and you need to enable this for each policy. I've actually written a script that you can use to just enable them or disable them en masse. But there are some caveats here. So the first one is, again, this was written way back in the day and it hasn't been updated yet. So in my testing, I found this to be safe for single session machines. Multi-session machines, I would not enable this for. And the reason for that is the assumptions they had back then are no longer applicable today. So when they write to the log files, you can actually lock that log file mid-logon by opening it in Notepad. And then what ends up happening is the user just sits there with that logon, you know, applying group policy registry or whatever. And that's because if that log file is locked, it will not proceed logon until it can continue writing it. So make sure you have AV exclusions for these files because AV will lock it, especially if it's getting written to constantly. And that's also why you don't want to enable it in multi-session because they can trade locks during that contention period. Last, and this one is a tough one. Use the newest operating systems. And there are challenges with the newest operating systems, but there are some positives. Especially with Server 2016, the WinLogon log was completely broken. Wasn't logging anything. Server 2012 was fine, Server 2008 was fine, Server 2019 is fine, Server 2016 was not. As well, they've made more detailed logging available in Server 2019 and 2022 that we can use to identify these logon phases. But the challenge with using newer operating systems is Microsoft is adding these new features and using technologies that they had no consideration for the performance or impact on the logons. So if you have AppX packages, which all new operating systems come with and newer operating systems come with more, they tend to negate these benefits. But it's something that I strongly recommend just because the more information that the operating system provides, we can actually give you more information as to what those phases and what's consuming your time. So understanding your logons. So next, the tools that I use when I'm troubleshooting logons. So these are the tools I use. I use Control Up. I use a series of PowerShell scripts. I use Process Monitor, Xperf, and WPA, and log files. Unfortunately, I don't have enough time here to go into how to use these tools, but I will try to do my best as quickly as possible here. So first one, Control Up, and I do have one caveat here, and that is I do work for Control Up. So conflict disclosure for sure, but what Control Up does is it allows you to see out of the box the high-level logon stages, and then all of the scripts that I'm going to show you, you can execute through Control Up without having to know the parameters that you need to feed into them. So this is what it looks like in Control Up. You've got your logon duration along with your profile load time, group policy load time, desktop load time, and logon duration other. I always get lots of questions, what is logon duration other? And it's any time that's consumed in your logon that's not a part of the other phases. It just gets dumped into there. We might know your logon takes 1 minute, and profile load time takes 5 seconds, group policy load time takes 5 seconds, desktop load time takes 5 seconds. That's 15 seconds of time. 45 seconds, I don't know, so we dump it into logon duration other. But we have tools to actually identify what logon duration other is and what was consuming time there. So this is the fun part. I want to get into the PowerShell scripts. So I'll flip here and I'll let you take a picture of this because these PowerShell scripts, I highly recommend you download, check them out. All the parameters and stuff are listed in the header so you can actually see what you need to input to get the best data out of them. Ideally, just use Control Up, right click on an object and execute, but if not, it's open source, you can check it out for yourself. So I'm going to get into the first one. This one I have a lot of help, a lot of contribution for, the Analyze Logon Duration script. And so in my humble opinion, this is the best tool for understanding your logon durations. It was originally written by a gentleman named Niran Korin. And Guy Leach then, if you haven't heard of the great Guy Leach, he's a great guy on Twitter. He does lots of dad jokes. He took the script and he optimized the heck out of it in 2018. So he added run spaces to make it more efficient and faster. He optimized a lot of the code that I wrote and stuff of that nature. So he did a great job. The current primary contributors to this script are myself and Guy Leach. And it's commonly abbreviated to ALD. So if I refer to it as ALD, then I'm referring to the Analyze Logon Duration script. So a little bit about it. It's 5,600 lines of code. It does use dynamic C# compilation in order to get some certain information out of the system. Uses numerous run spaces for accessing the event logs. It's fully open source and it's supported by Control Up. The challenge with using C# dynamic compilation is some of you out there have like really secure environments that don't allow scripts with dynamic compilation to execute. And I'm really sorry, I don't have a workaround for that today. So if possible, if you can execute it, then it's great. But if you deny that level of execution, then unfortunately this isn't going to work. So a little bit about the features of it. It does track 9 logon phases, 27 pre-logon, or 9 pre-logon phases, 27 logon phases. We track 5 different vendor technologies today. I'm certainly interested if you have a unique piece of technology that you want to see added into it or that you think is impacting your logon to reach out to me, and I can certainly work with you on seeing if we can find markers to add into it. So these are those logon phases and pre-logon phases. You'll see for the pre-logon phases, we do a fair bit of tracking that. And the reason for that we do the pre-logon phases is when I was working with those doctors and they click on that icon, you would see it spin, and then eventually you would see the Horizon client come up, and then they'd start getting to the desktop. Well, when you ran Analyze Logon Duration or a lot of these other tools that track logon duration, they're only tracking it when you're connected to Windows. But there's actually a long period of time from that click to when they're eventually connected to that desktop. And if you're sitting there with the doctor doing the stopwatch, that might be 30 seconds of time. So it's really important to try to get that pre-logon phases as well so you can fully understand the experience that your users are having. So some of the features of it, some additional features of it, it also tracks Apex package load time, so you can really get you can really feel along with me the hate for Apex packages. We also track WMI filter duration, client-side extension, aggregated duration, scheduled tasks, RSOP login state, loopback processing mode. I won't go into those and what they are, but I do have blog articles out there. If you search for Trentent and RSOP or just Trentent RSOP and loopback processing mode, I will tell you why it's important to have these values set in a certain way. So some advanced features of it as well, it creates offline analysis packages. It does a do your best analysis. So if you don't have all of the prerequisites enabled, it will try to provide you as much information as possible. We try really, really hard to make it so that way it gives you something that's actionable if you don't have the prerequisites completely enabled, but highly recommend you do. So this is what it looks like. I'm using a Citrix example here, my apologies, but I'll run through it anyways. So at the top, we've got the header here. So we've got username, the loopback processing mode set to replace, so good for me. RSOP logging set to disabled, so good for me. We track the logon duration start and end. In ALD, if we have the pre-logon phase, then we consider that the logon start. We actually don't consider it when the Windows one begins. So in this particular case, you can see it's 196 seconds, but the actual Windows duration when it connected to the Windows machine was 172 seconds. So there would be 20 seconds that a doctor would have on his stopwatch that you would not have if you just looked at the Windows portion. Then we have the pre-logon phase itself. Next, so this is the actual meat of it when you get into the Windows logon duration. So this is when it's connected to Windows. You're seeing that please wait for Windows. This is what that's doing during that time. So we track the source from all the different technologies. So Windows, FSLogic, Citrix, VMware, Avanti, and the shell. So the shell is when Explorer starts. We look at the different phases as they occur. So the Windows logon time, load profile, RSOP, et cetera, et cetera. You can see all that here. We can see we've got the 2 Apex phases here. So interesting thing here, Microsoft had moved file associations in Server OS to be higher up. So they don't have it as part of the shell. So that actually gets removed from the shell processing. But they still have the Apex load packages actually in the shell phase. So unfortunately, in Server OS, that gets removed, but this one doesn't. So some time is saved here, but not there. I can't explain the logic. Next, the duration. So this is pretty easy. Take the end time, subtract the start time, you get the duration. So that's how long all of these phases took. Gaps. I get questions about gaps quite often. So what is the gap? Why is it there? So what a gap is, it's an unexplained time. So an unexplained amount of time. So in this one, we've got a really good view of all of these phases, and there's almost no gaps between. Well, these little gaps here, these 0.1 seconds, 0.6 seconds, usually that's transition time. That's like context switching from the logon phases, from ending one phase of the logon to starting the next part of it. You know, if it's reading a file, like it's reading the CSV, it's actually stored in an XML file, so that amount of time isn't stored in any logs, but it still takes time to process it, and if it takes 0.1 seconds, unfortunately, since there's no markers, it just goes into the gap, but that's what it is. If you see a long gap, that's when I really get excited. So that's when you reach out to me and you say, hey Trent, we got a long gap, can you help me out? I'll I'll hop on a call with you and we can actually do a procmon trace or something like that to see if we can identify it. Underneath, WMI filters. So this was an exciting feature I added last year, WMI filters. So when you have WMI, who here uses WMI filters on their GPOs? Too many people. But the challenge with WMI filters is, do you know how long the query takes? Most people don't, right? So in this particular case, it's actually select star from Win32 product where it happens to be Citrix, or you can have VMware or whatever. This is the worst WMI filter you can have out there. So what this does a repair reinstall of every installed application on your system. I don't know why they designed it that way, but then it got out there that this is what you use to check to see if a program's installed. This is the worst thing you can do for your group policy performance. I was on a customer call where we originally designed this feature because they were having such long logons, and we found it was WMI that was doing it, and they were using this filter. So this filter was direct from them. Crazy. Next is the Apex package load time. So a little caveat about Apex packages too. You can see that they've got all these durations here, but it may not add up to the total time that it took to load when you saw it earlier in the analysis. And the reason for that is Apex packages are loaded both synchronously and asynchronously. So they're loaded 2 at a time. So if you've got package 1 and package 2, package 1 completes, package 3 then starts. Package 2 finishes, package 4 then starts, and so on and so on. So you're stuck with this little laddering effect here. So the more Apex packages you have on your system, the slower your logins are going to be. So 100% remove as many as you possibly can. Last is non-blocking tasks. So this, or second to last, non-blocking tasks. So what these are what I call CPU suckers. So because logon duration, the logon process is a single-threaded process for the majority of it, these guys will steal the CPU that you're using to actually do your logons. So if you can, disable as many logon scheduled tasks that occur during your logon. And some of these are just really confusing. We are not an Azure Active Directory environment, but sure enough, it checks to see if it needs to join Azure Active Directory. So disable that logon task, save some CPU cycles, see if you can get some fractional performance in your logon duration. Next is client-side extensions. So these are all client-side extensions that are occurring in your environment. You can see I actually got one here, group policy shortcuts. It's got 15.2 seconds. It's just on one group policy, thankfully. If there was multiple group policies, this is an aggregate metric for your client-side extensions. So it actually becomes quite difficult when you've got like 30 or 40 client-side or group policy objects to identify which one was the cause. But don't worry, I have a solution for you there. Last is just a little informational message. So I did just add, I believe just a couple months ago, some support for DEM within Analyze Logon Duration. We did find that these two features, path-based import and async actions, were causing delays for a particular customer. So I did add that into Analyze Logon Duration. So we are doing some DEM event there, which does cause some delays. So if we wanted to understand the group policy object that was actually causing the delays, we can use analyze detailed GPO duration. So this is a PowerShell script that I wrote. It breaks down the individual group policy object performance for the client-side extensions that are processed within. You can identify the individual GPO that's causing the lag. It does require that logging to be enabled, because without that information, I can't help you out. I built a little feature within that script. You do -enable, boom, all of the logging's enabled for every CSC on there. Set it to -disable, all the CSCs are now disabled for logging. This is what it looks like. So we got the user header at the top, logon time, and then when the group policy preferences policy event time started, there's an initialization time. It's negligible most of the time, about 150 milliseconds or so per group policy client-side extension. Now I've got two outputs. One is GPO processing breakdown per client-side extension per GPO. So here we can see EUC common settings took 1500 milliseconds for the group policy registry, and it also took 2 seconds for group policy registry processing as well. So if I go down further, I can actually get it broken down per group policy object. So I can see the majority of my time is spent in this one particular group policy object. It spent 17 seconds there. So now if I wanted to optimize it, I could target just this specific group policy object to see what I can do to make this better. All right, next is a remote event log tailor. So this is a really cool script by Guy Leach. It aggregates events across multiple machines. It leverages the out-grid view for the events. This is what it looks like. So once you start executing it, this is all in real time. So if you do this during a logon, you'll see pauses in it, and that's when processing is occurring. So it's actually really cool for watching the events, and as they flow through, seeing a pause, and if you can check what that last event was, then you get an idea for where it's being delayed, and then you can start targeting that particular piece of information or that particular technology for optimization. Next, Procmon, trace system activity. So Procmon is a beast in and of itself, and the biggest challenge with Process Monitor when you're talking VDI is how do you execute it in a single session machine? And that's where Control Up comes into play. You can right-click on your VDI machine and run this particular script action, and then it starts logging, and away you go. So it does have some advanced features. It will auto-download Procmon if you don't have it in your environment. It can drop filtered events, so that way it reduces your CPU load. You can specify additional custom filters, and it can save the log file to custom locations. So these are what the parameters look like in Control Up. You can look at the header of the script for them and actually look at the examples as well, so you can do that manually if you so choose. So just some hints. Try to reduce the data set. Run analyze logon duration on the Procmon data set that you have. Exclude events before and after so you minimize the amount of data you're going through. You saw in the ALD output, they had the start event and end time. So if you wanted to look at a particular piece of technology, find that timestamp, exclude events after, exclude events before, and then just look at that data to see what it's doing. All right, last one is event log aggregator. So this is essentially the remote event log Taylor script, except this is post facto. So this is after the fact of a logon. So what you can do, it's a really cool script. Again, by Guy Leach, this guy's amazing. Aggregates events across multiple machines. So if you target it on a broker machine along with your VDI machine, you can actually see the information flow. Really, really neat. It'll put the events in chronological order for you. So make sure you're using NTP time and all that other stuff to make sure your time is in sync. This is what it looks like. So it looks very similar to the remote event log Taylor. So again, you run analyze logon duration, you start looking at those timestamps, you go down to the timestamps, you can see what's happening. So this is AppX. This is what the AppX packages are doing, or some portion of it. One portion of AppX is it loads into the start menu, and so that's where you see the start layout population. So we run this script and we start looking at those timestamps and we start understanding what those packages are doing, what it's doing during this time. So this is an example of that. So as I said, I did have a lot of resources. You can come check me out at the Control Up booth as well. I can share these resources for you, but I've done a lot of work on analyzing logon durations, helping a lot of customers, helping a lot of people like yourselves who want to do better in your environment. And you know, a rising tide raises all boats. So if we can do that for you, then, and we can make your environment more efficient, we can make the doctor care and the patient care better, that's like a personal goal of mine. So it doesn't have to be a doctor's office. You could be in finance or technology or anywhere else in the industry. But if we can reduce these logon performance to get people as productive as possible, as fast as possible, I want to make that happen for you. So, and those people who want to make it happen for themselves, these resources hopefully will help you out. All right, and thank you so much.